to stop sharing my screen, and I'll hand over to you, Monique, to
Thank you, Jared.
take it away.
Just to get this started. So one more. Okay, I think we're set. So thank you very much. Yes, I've been in education, checking I'm not on mute, am I? No. Just I've been in education for quite a long time, and I'm really happy today to be supporting Matific. One of the things that I think is a point of difference with Matific is their real focus on making sure that students have conceptual understanding embedded in their platforms and doing that in a really engaging way. So let's get started. So I respectfully acknowledge the traditional owners and custodians of the lands on which we meet today and pay my respects to elders past, present and emerging, for they hold the memories, the traditions, the culture and hopes of Aboriginal and Torres Strait Islander peoples. I am coming to you from Yagara and Turrbal lands today, which is kind of a cross between the Moreton Bay language groups of the Aboriginal and Torres Strait Islander peoples and more what we now know as the city area. So yes, Jared's gone through basically what I'm going to go through today. Structure is very similar really to what we have seen in Australian curriculum mathematics previously. So the Australian curriculum generally remains a three-dimensional curriculum. So that means it has the learning areas, it has the general capabilities, and it has the cross-curriculum priorities. Some of those terms have changed slightly. They were all reviewed as part of the review process, and there was alignment done between learning areas and between the general capabilities and cross-curriculum priorities to have that alignment across all of those three dimensions, which was a really exciting part of the review. Now, the reason I put that slide on there, although you can't, and I'm going to be summarising in a second, I wanted you to see the vast difference in the comprehensive nature of the rationale. So the curriculum has been updated to reflect our 21st century understanding of the what and the how of teaching mathematics. And as professional educators, we need to have an understanding of the learning area, and not having that based on what we think our understanding is. We all generally know what mathematics is, but what is the mathematics learning area? And therefore, then our teaching and our understanding will be reflected in what has been developed through the curriculum. So this rationale section provides information on that big picture thinking of the curriculum and gives you the overall statements that position mathematics as an essential and powerful area of study, and one that our students will want to be engaged in. So here's a little bit of a summary or key points from the rationale. So it's central to learning, key to the development of numeracy capability. It has beauty and power. Now they're two interesting words to have in a curriculum rationale, beauty and power. It's integral to quantifying, thinking critically and sense making. So very strong 21st century skills. And it needs to have an opportunity for practice, inquiry and active participation in relevant and challenging experiences. And only in that way we're going to have students progress in their mathematics understanding. So that little quote on the right there kind of encapsulates, I suppose, the vital information around what the researchers and practitioners were thinking about what they wanted for their mathematics curriculum. So when I read through the rationale, these words are kind of the ones that stood out to me, and phrases. So to me, the message about Australian Curriculum Mathematics version 9 is that there is a real balance between that expectation of mastery, and that is still there, and the use of, and the ability to be proficient, and have an expectation for opportunities for students to be creative in their mathematics, to problem solve, to reason, and to develop that positive disposition to the discipline. Now, interestingly, one of the head writers, she didn't write it, but she facilitated the review. she had very strong overarching focus on students developing a positive disposition. And you'll see that in the level statements that when we come down to that section. So part of the Understand the Learning Area section is the aims. And again, I've just placed that there to give you an idea of the comprehensive nature of the aims in version 9 compared to version 8.4. So these are the key aims, and they're what we desire for our students as they engage in the curriculum from foundation through to year 10. A summary of some of those points in the aims. We want them to have proficiency in use and communication with mathematics. We want them to have skills in investigation, interpretation, representing, and critical thinking. We want them to connect mathematics to other disciplines, and that's where building numeracy capability comes in. We want them to have that positive disposition. We want them to enjoy math, see it as useful, not have that question of why are we learning this? What is this used for? We want them to extend their knowledge to specialist knowledge, and we want them to continue studying through the senior years. Now, that is a very important aspect of us in the primary sector, is building that positive disposition so that they have it in the secondary area. And the quote on the right encapsulates that again. When I read through the aims, these are the verbs that stood out to me about what it was we want our students, or what I thought was important that we want our students to do through the learning area of mathematics. Now, there's a strong message here when you glance through those verbs, and that's that mathematics needs to be experienced. And in version 9, this has been clarified. It's shown as clear aims around reasoning, interpreting, modelling, and to maintaining a fluency with skills, processes, and procedures. And of great importance also is that through our teaching, we instill that positive disposition to mathematics to our students. So version 9 of the curriculum provides clear understandings about the proficiencies of mathematics. Now, as with all new curriculum, there's all these words. So I've already said things like mastery, proficiency, processes, procedures. So it is important to get a bit of an understanding about what all of those words mean and how they're connected. So the proficiencies of mathematics are referred to as proficiencies, and they contribute to the expectation of mathematical proficiency, positioning them as included in the content, not separate to the content as they were positioned in version 8.4. Now, the Understand the Learning Area section provides even more detail about the proficiency specifically, and it is important to have that clear understanding, and I really encourage you to go through that Understand the Learning Area section on the ACARA website and really understand particularly that proficiency does not mean that it's directly connected only to speed and only to instant recall. Proficiency includes having connections with and between skills and understandings, not just a parroting or a rote vocalizing of facts. So key points about version 9 regarding the expectation of proficiency is that proficiency occurs through the proficiencies. So through fluency, through reasoning, through understanding, through problem solving. It's developed through concepts, skills, processes, and procedures. It allows for students to respond effectively, and there's that communication aspect. And it allows for students to evaluate and verify effectively. Evaluate and verify are very important 21st century skills. And again, that little quote that I've put there kind of gives you an idea of what they're trying to get for our students through those proficiencies. Notice that it says increasingly sophisticated and refined. So you may not be particularly familiar with the proficiencies. If you have had a lot of engagement with mathematics teaching and with version 8.4, the great thing is that the understanding of 8.4 and the understanding of the expectation of proficiency has really been leveraged from that curriculum. So version 8.4 is still very relevant in regard to the proficiencies. And Professor Peter Sullivan, who is the head writer of version 8.4, has really shown a great way to understand the proficiencies through that quote. So if you want to have a glance through, an important thing I think about what he says, especially about problems, is that a problem shouldn't be something that you already know the answer to, or that you already know how to work out really quickly. You need to be able to persevere and have some challenging tasks in order for it to be a problem. So I really like that, those definitions, just to help get those proficiencies straight. So the structure of the Australian Curriculum version 9 is similar to version 8.4, and this section provides information on the connections between the parts of mathematics and how it has been structured intentionally to enable teaching and learning connections between all of those aspects. So what I'm meaning there is that it's been organised still from foundation to year 10. The strands have now been separated, and they've been separated in order for you to see their connections, which sounds a bit of an unusual thing to say. So there's 6 interrelated strands, separated so that you can see more than just the double strand relationships. So there are some natural connections between strands. There's natural connections between number and algebra, but there's natural connections between number and measurement as well, because measurement provides for us some of the context of how we use number. So they've been separated in order for us to see that a little bit more closely. They've also, the strands also provide all of that relevant content to be spread out. Now, fairly new, I suppose, are the mathematical processes. So some secondary teachers are very familiar with mathematical modelling. However, the processes of mathematical modelling, computational thinking, statistical investigation, and probability experiments and simulations have been explicitly identified in version 9. And an interesting little point there in blue on the right there, the way that money has been approached in version 9. So except for a couple of explicit content descriptions, money is predominantly approached as a context within number and not as its own content. So to be honest, during the early stages of the review, I struggled with that a little bit, but throughout the process, I can see now that that's entirely relevant. I was looking today at version 8.4 for some work I had to do. And in version 8.4, we are asking students to represent in dollars and cents, yet they haven't learnt decimals yet. And so I can see those connections with number, and I'm really pleased that money has been thought of in that way. I mentioned the mathematical processes. So these are the thinking, reasoning, problem solving, and investigation process skills involved in working mathematically. I've mentioned what they are and they're listed there. So if you're thinking of really the ways that we solve problems in mathematics, and we'll talk just a little bit about each one in a second. So computational thinking. So it is developed through a process of decomposition, abstraction, pattern recognition, models and simulations, and algorithms and generalizations. Now, there has been strong work done with the technologies curriculum, and I bet I've said that incorrectly, but a lot of work was done to make sure there was alignment across learning areas. Now, computational thinking content begins in year 3 explicitly. Mathematical modelling can be used to provide insight into and make predictions about real-world phenomena. The processes utilise mathematics to formulate, analyse, solve, interpret, generalise, and then communicate results. Now, we got a little bit of an insight into the importance of mathematical modelling during our COVID time, and it was used all the time. Mathematical modelling was used to model and predict how many cases we're going to have. Our politicians used it to make decisions about lockdowns and about all of those rules that we had to follow. So mathematical modelling has really come to the fore in what it is used for, and that is to make predictions about real-world phenomena. Now, mathematical modelling content begins explicitly in year 1, although in the foundation year, there is some representations of situations, I think, from memory. Statistical investigation is one of the other processes, and it begins with just informal exploration and develops with guided processes, leading students to plan, conduct, and review their own statistical investigations, and also to critique others' processes and conclusions. And that's another important part of that critical numeracy, being able to evaluate and justify your own position. So a statistical investigation in a guided sense content begins formally in year 3, but there is content around collecting and recording data beginning from foundation, or in Queensland, we tend to call it prep year. Probability experiments and simulations. So they begin with exploration, as similarly to the statistics, and progress to conducting chance experiments. And then the simulations need to involve digital tools. And that allows students to then have access to those really large data sets, which then allows you to be able to make predictions, have some critical numeracy around that, thinking about generalizing from a small sample. That could be because there is great connections between the probability strand and the statistics. And the probability content begins formally in year 3, which is pushed back quite a bit from version 8.4. But remember that in foundation year 1 and year 2, students are still familiar with the way we talk about chance. You know, it's highly likely it will rain today. Oh, it's impossible for us to do all of these things. So I would still encourage you to have those conversations with your students in foundation year 1 and year 2, giving them a little bit of that background familiarity prior to it being formally introduced in year 3. Now, the curriculum is organised in the following sections. So we've got level descriptions, the achievement standard, organised in aspects, the content descriptions, and the content elaborations. Great thing about version 9 is there is alignment right through from level descriptions to content descriptions. Content elaborations provide more information, and then there's alignment straight down to the achievement standards. So that's a really great step in the curriculum. And as I mentioned before, there's also alignment across learning areas. So these are the definitions of what all of those things are and what the expectation is. So the level descriptions provide information about the learning contexts for each year level. Content descriptions specify what teachers are expected to teach. Content elaborations are optional and provide suggestions of ways to teach the content. And the achievement standards, which describe what students should typically demonstrate by the end of each year, or in some other learning areas, it's a band of years. Speaking from a Queensland perspective, the achievement standard represents a C standard for us. So this unpacks that a little bit more. So the level description, which is the top statement there, comprise the information about the what, but also the how for your particular year level. So further information in that positions the importance of the connections that enable the development of proficiency and the development of a positive disposition. And that is shown in all of the level statements. Each level statement has, each year level has the same level statement at the beginning, positioned right there. That is with the exception of the foundation year, because it references the kindergarten and early learning guidelines. And then more specific information is included. So this particular one is from year 2, and I've just pulled out 2 of the many content specific parts of the level descriptions. So you can see that in pink, you've got, kind of the content, and then the role or the how of doing that is shown kind of in the red. So they've tried to give you that both, the what and the how. And there's also some hints towards pedagogy in there too, that in this particular one, play-based and practical activities. This is one from year 5. Level description is the same at the top, But further down, we've got the content, which in this case is around percentages and proportional comparisons. And then, you know, what's the role? Well, it enables you to the students to develop some reasoning skills, and they do that when they're looking at the relationships between events, etc., as listed there. So that's the level descriptions. Now we're into the content descriptions. Content descriptions specify what teachers are expected to teach. In version 9, content descriptions are embedded with proficiencies and processes, and they guide teachers as to the how of mathematics for that content. And within this, and I mentioned it earlier, there are kind of hints as to the pedagogies that can be employed. Now, the content descriptions were crafted specifically and intentionally to have knowledge, skills, and understandings, to have concept, skills, procedures, and processes embedded where appropriate, and to have an overlying thinking around disposition. So here is an example of a content description from year 1 in the number strand. So quantifying sets of objects is what the students are going to have an opportunity to do. There's a little bit more information there, clarifying information, and they're going to do that to at least 120. How are they going to do it? So this is a bit of the information on pedagogy. They're going to do it by partitioning collections into equal groups. And then what processes and proficiencies are embedded? Well, we have to work that out a little bit, but using number knowledge and skip counting implies there's some fluency involved in there, and there's also some understanding. That particular content description doesn't have a process embedded. There's no mathematical modeling, there's no statistics investigation, there's no computational thinking, and there's no probability in there. And that's highly appropriate. Looking at this year 5 one, again, what are they doing? What's the content? Create and use algorithms. What's some more information? Well, they'll do that using a sequence of steps and decisions, and you need to use digital tools. What's some information on pedagogy? Okay, well, they're going to be experimenting with factors, multiples, and divisibility. What processes and proficiencies are there? Identify, interpret tells me reasoning. There's understanding and a bit of fluency in there. And they're describing emerging patterns. Now, it's not completely evident in that blue text that there's a process involved, but when I go back up to the algorithm, knowing that my definition of algorithm is around a sequence of steps and decisions, then that tells me that computational thinking is one of the processes involved there. Content descriptions need a little bit of unpacking. And when you're reading them, you do need to unpack them with an understanding of that structure and how they've been written. Okay, so the achievement standards, they describe what students should typically demonstrate by the end of each year or band of years. Now, I don't know if that's a national position. I'm speaking from a Queensland position. I think that's a national position, but you will know your own jurisdiction. They're organised into 3 paragraphs, so we're back to the double strands. And achievement standards, because there's alignment all the way through, they also have proficiencies and processes embedded. So an example of just year 1, so I've just pulled the number and algebra year 1 aspects out of the achievement standard here. So you can see how they're kind of crafted, and there's that year 1 content description we looked at earlier about quantifying to at least 120, and there it is with the alignment straight back to one of the aspects in the achievement standard. And again, there's that year 5 one. Again, the algorithms, there it is shown in the number and algebra for year 5, so one of the aspects. So the content elaborations. Great thing about the content elaborations compared to the elaborations in version 8.4, they're much more comprehensive. They provide ways for the general capabilities and the cross-curriculum priorities to be embedded, which is really handy as a teacher when you're trying to do so much in one go. And also they provide authentic opportunities as one of the cross-curriculum priorities for some First Nations perspectives to be embedded. So the head or the CEO of ATSMA, Aboriginal and Torres Strait Islander Mathematics Alliance, Professor Chris Matthews, he's got some free lectures online if you want to look him up. he calls himself an anomaly because he said he is an Aboriginal man who succeeded in mathematics despite all the challenges that he's had growing up as an Aboriginal person. He led the team that wrote the First Nations elaborations, and they're really interesting, and they provide some confidence as a teacher who has very little knowledge on how to bring an Aboriginal perspective to the classroom. It provides that little bit of information. So the elaborations are optional, but they help you not only do what I just spoke about, but they also help you to unpack the content description a little bit. If you're not really sure what it's getting at, it kind of helps you to understand that a little bit. So we've gone through kind of all of those labels and structures and organisation, etc. And one of the underlying parts of the Australian Curriculum Review was to ensure that there was a definite build-up of learning. Very important, you know, being in the primary, sometimes it's hard to know, you know, how your students have achieved later on. And you think, oh, I'm just doing this sabotaging activity, you know, does it really matter if they understand that? And I'm hoping that you'll see that in version 9, you can see that those foundations that we lay in the primary are just vitally important for how students have success in secondary. So this is an example of that building up of learning that is evident in version 9. So I've just grabbed one of the content descriptions from the algebra strand, and it's focused on patterns. So you can see on those first couple of boxes, we've got, you know, recognizing, copying, continuing, repeating patterns. That goes on to creating repeating patterns, and a few more bits are added. They're describing, they're going into, you know, more addition and subtraction, looking at inverse. You can see the number being connected in there. Partitioning, more number. So that's the foundations being laid from prep to 3, or foundation to 3. How does that progress further towards the other half of the primary? Well, now we've got into further connection in number with unknown values in equations, really digging into that inverse relationship knowledge and properties of numbers and operations. Becomes much more sophisticated when we hit year 6, and you can see that year 6 area really laying the foundations for the junior secondary. Let's have a look at the junior secondary from looking through in that building up of learning. And then we've got use of variables, formulas, substitutions, graphing, and then more advanced algebraic applications. So you can see how much more sophisticated. Now, if we glance back to where we've come from, all of that has come from that recognizing, copying, continuing, repeating patterns, and just the building up as we get through primary into the secondary. So that is part of connecting back to the aims. Part of the aims of the Australian curriculum was for students to have that more sophisticated and refined, and that's an example of it there. So 2024, it's going to be a little bit different to what 2025, etc. will be. And I hope that what I've given you so far is a little bit of an unpacking of the learning area at least. And of course, I do encourage you to go to the website because it has really great functionality where you click on something and it shows you all the connections. It's great to have a look at. There's a video tool you can do in there, which is really wonderful. So what does this all mean though for you and your planning when you implement in 2024? Now I'm speaking from a Queensland perspective. We have to implement English and maths in 2024 in the primary. You need to just have a little bit of consideration in your planning is that 2024 is a little bit different because your students possibly may not have the expected curriculum background knowledge coming into version 9 that they, because they're coming from version 8.4. So that's just something to consider. So I've just done up a really basic template that might help with that. So things we have to consider, well, what's the previous year changing content? What about the aspect of the achievement standard? How is that going to affect assessment? What's my current year changing content? Do I as a teacher, understand that content myself? What am I going to have to change around my planning and my processes, etc.? And how am I setting up my students for that next year changing content and assessment, looking at the achievement standard? So, you know, we are bringing students into a transition, and we're also getting them ready for it, for, you know, their first time going into the next year level in that, with the version 9 as well. So possibly something like this may help to organise your thoughts. I've done a year 5 one there, so you can see that, you know, new to year 4, meaning that an expectation year 5 will have already engaged in this. They're multiplying, dividing natural numbers. Refined in year 4 is about grid reference systems, and removed from year 4 is comparing objects using familiar units of metric units of area and volume. So, you know, there's some changes there. You can see further down the current year change in content. So if I'm a year 5, you know, I don't have to specifically or explicitly teach additive patterns with fractions, decimals, and whole numbers. There might be a replacement that goes, that touches on that content. And then in terms of the achievement standard, of course, we've got all those things around mathematical modelling, computational thinking, etc. that will be in the achievement standards that haven't been in there before. So that's just something to consider. And that kind of brings me to the end of my formal part of things. Jared, will I hand over to you now?
Yes, thanks, Monique. We've
I
got
will
we've got one
unshare.
question there waiting for you already.
Perfect.
Oh,
good. You took over already. Excellent.
Yeah. So this is a chance for two things. Basically, I'll give people a quick little overview of Matific, and during that time for other questions to go in that Q&A section. So we will progress with that, and the information now about Matific itself. So the question, you know, we always like to ask people is to think about what are your students doing when they're on their screens, and how well is that reflective of what we're actually trying to do when we're looking at implementing the Australian curriculum. And, you know, the concern often is that the curriculum can change, but do we in fact see that change translated in the resources that are presented to people to use? Just hide this one. So unfortunately, often, you know, all we get are digital worksheets where the students are posed a question in an abstract way, and they're not actually presented with the models, the manipulatives, the context, the language, and so on, in order to assist them in developing the conceptual understanding that really is required if we're going to get our students to not just be little calculators, which they have in their phones and their computers, but to actually be problem solvers and people who can reason and solve problems through that reasoning. So what sort of activities do we have? What sort of pedagogy do we demonstrate? So in Matific, we want kids to take risks. We want to support them. One of the nicely, particularly in a Queensland context now, is that a lot of schools this year are getting upgraded bandwidth. And I have had a tech person at a school say it was because of the demands that Matific places on their bandwidth that he knew it would be a resource that was very rich and not one that simply was just giving digital worksheets. But unfortunately, up until now, they haven't had the technology to enable them to actually use these sort of state-of-the-art resources like we have. So, you know, when we look at what we do, we're trying to emulate the same sort of good practice you do in hands-on mathematics. So instead of here using the big, heavy and expensive weights and so on, we're actually presenting them in a digital format, but we're giving children the models, whether it be the scales or using a digital protractor in this case here to measure the angles. So it's a lot of fun for the kids because it's an engaging context with the shooting the cannonball and dropping the person into the water. But it also is giving them a chance to use that particular tool, just doing so in a virtual way. Now, when we're looking at multiplication, giving them models of area so they actually can see that what we're getting from the length by the width is actually about covering an area. And we do that through this activity, but we also do others where the kids have to form grids and draw out those sort of measurements themselves. So chance and data are all sorts of activities for all aspects of the curriculum, and people using Matific already would be aware that you can search for content, and I'll come to that a bit more soon, in a variety of ways, and that includes via the new version 9 of the Australian curriculum, or if you wish at this point to still be working with the 8.4, because it's not till next year that we're really required to do that next implementation phase. So as I said, we've got a variety of ways in which you can search for content. When you choose your way of searching, that will remain your way of searching unless you hit the little drop down and choose to go to either textbooks, where we use Oxford Maths or Maths Plus, if those series are something you're using, or you can just search by topics. You'll by default search for content from 1 year level, but you can tick the box for multiple year levels, and then the activities for all the different levels will be laid out for you. And then those activities can be assigned to the students at a class basis, group basis, or individually, and you can schedule them. So you don't have to assign them immediately. You can schedule them so that they become available to the students a particular day and time of the week or some subsequent